In this video, we're going to take a look at solving and graphing a linear inequality. So I have the linear inequality, y is greater than or equal to 2/3 x minus 4. So we're going to graph this just like we normally would a line. -4 is my y-intercept, and the 2/3 is my slope. So I'm going to place a point at -4 on the y-axis, and then I'm going to go up 2 and over 3 and place another point there, up 2 and over 3 one more time. And I'm going to connect those points. I'm going to connect them in this case with a straight or solid line. So whenever I have a greater than or less than or equal to, I'm always going to use a solid line. That's to indicate that all of the points on the line are in fact part of my solution. If I have a greater than or a less than sign, then I'm always going to use a dashed line. And that would be to indicate that the points on the line would not actually be solutions to the inequality. So now that I have my line shaded, I need to also shade one of the regions on my graph. So I'm going to choose a test point of 0, 0. And I'm going to plug 0 in for the x and 0 in for the y of my original inequality. And I'm going to check to see if that point 0, 0 does work in my inequality. So after plugging it in, I get 0 is greater than or equal to -4. So that is a true statement. So that means that the side above my line must all be points that are true. And for that reason, since they are all true, I'm going to shade above my line. If they were not true, then I would be shading the area below my line. So let's try that again. Now in this case, I need to get the y by itself before I can graph the line. So I'm going to solve for y, so I'm going to move the 4x over to the other side. So that's going to become a positive 4x plus 8. Then I'm going to divide by -2. I'm going to divide everything by -2. So I get y is less than -2x minus 4. Now why is it less than in this case? It's less than because when I divide an inequality by a negative number, I need to remember to switch the direction of the inequality sign. So I'll plot my first point at -4, so that point is at -4. Then I'm going to go down 2 and over 1, and down 2 and over 1 again, and I'm going to connect these points with a dashed line. So I'm not going to connect this line. Now again, I'm going to check the point 0, 0. 0 is less than 0 minus 4. 0 is less than -4. That's what I end up with. That is a false statement. So since that statement is false, the area where the 0, 0 is must all be false. So I can't shade that area. Instead, I have to shade the opposite area. In this case, the area below the dashed line.